To most of us, these are just preschoolers playing games of pretend. But some of Berkeley's top scientists will say that much more is going on here than simple child's play. They see very young minds at work processing very high-level calculations about how the world works. The kids are even inspiring computer scientists. A variety of new research on babies and young children is revealing how well and how early in life we humans are able to perform complicated thinking tasks involving things like inductive reasoning and probability. Pretend play has become a powerful research tool.
Happy birthday to you.
In Professor Alison Gopnik's cognitive development studies, experimenters use children's natural ability to pretend to get at how their mind works. They find that children are actually hypothesizing.
That kind of hypothetical thinking, sometimes philosophers call it counterfactual thinking, because it's thinking about what could happen, not what actually did happen. That's a very, very powerful kind of thinking that we use in science.
Are you ready for our game today? Yeah, okay.
In one experiment, researcher Sophie Bridgers tells children it's the monkey's birthday and suggests they surprise it by singing Happy Birthday. Then she shows them a special box that plays music when something called a zando is placed on it, but not when something else is placed on it.
Do you hear anything? I don't hear anything either.
Okay.
Oh, yes?
Hi, Sophie.
Hi, Allison.
Sophie, I need the machine.
After the music box and other objects are taken away, the children are asked to pretend they're still there.
And then we could still sing for Monkey. How does that sound? Right.
Even though children could easily pretend whatever they want, they seem to stay true to the script, only singing when the zando is on the box.
Happy birthday.
What we're showing is that pretend play, that very spontaneous activity that children are engaging in, is actually itself a reflection of this kind of deep learning and reasoning and understanding that's going on.
Other studies are exploring why children learn things better when they're asked to explain them themselves.
Now, why do you think this one made my machine play music?
Because it has a red and blue block.
They're using both the information that's coming in and also the information that they already have in constructing these new theories about how the world might work.
The results of these studies are revealing children's strong ability to think outside the box. Even more than adults, young children come up with unusual ideas for solving problems.
Because that doesn't happen in the real world.
Researchers are finding that by the time we're adults, we've lost much of the wide-ranging inquisitiveness that makes young children such good learning machines. In fact, scientists are now trying to build computer programs that can crack the code of a baby's brain.
Children are actually the people who are doing the most of this solving inductive problems. They're doing things like learning languages. They're doing things like figuring out causal relationships.
Tom Griffiths, who specializes in computational cognitive science, is trying to understand how people solve some problems better than computers. He's building mathematical formulas from the experiments with children.
What we do for our computer models is take exactly the same data that the children saw and give those to the computer and try and figure out what it is that would then lead the computer to reach the same conclusions that the children did.
One key question is how even infants seem to grasp probability. In one study, after seeing which lollipop the children like best, researchers show the babies 2 containers with differing ratios of colored lollipops in them. One container with more black, one with more pink.
I'm gonna get one. We think that the babies are sort of little experimentalists. So we think that they might be doing something like making guesses about what might be happening and sort of thinking about what they're going to get or what could happen. You want one, Henry?
The children most often crawl to the one that's more likely to have the lollipop they want.
Good job.
Which version of
Professor Fei Xu and her students in Berkeley's Infant Cognition and Language Lab are testing younger and younger infants.
In real life situations, we're almost always in a situation where things are uncertain. So we have to think about how probable something is going to happen, how likely something is going to happen. But we want to know, before language sets in, would young infants also have these really interesting reasoning abilities in place already?
Graduate student Stephanie Denison is monitoring the eye movements of infants.
The baby sees the experimenter reaching into the box, closing her eyes, and taking out what looks like a random sample of objects, and then they see what's in the box.
the babies end up staring much longer at the ones that aren't the color they expect.
Which one is it?
All this new research is leading scientists to believe that the reason humans have a longer childhood than any other species is because children are constantly learning, mostly by doing kid stuff, a finding that's bound to be useful in parenting and in education.
That everyday pretend play is teaching them just as much and things that are just as important as they would be learning if they learned, say, were in a reading drill. That's part of what makes the next generation of humans be able to learn as much as they can and imagine as much as they can and be as creative as they can.
This is super hard work.
At UC Berkeley, I'm Roxanne Makasdjian.
We need some water. Try